Hey everyone, welcome to our webinar today. We'll give folks a few seconds and then we will get started. We have an exciting webinar today. It's going to be a analytics face-off with a little bit of a twist we'll talk about here in a minute, but it's all going to be all about choosing the right technique for your research. So maybe get a few seconds here and we will go ahead and get started. All right, going once, going twice. We'll dive right into it. So today, I will be your host. I am Dan Fleetwood, the president of Research and Insights here at Question Pro. And today I have a guest, Chris Robson. He is the VP of Managed Services here at Question Pro. And I think you all should know Chris fairly well, but I'll read the short bio about him just in case you don't. He's a well-known industry expert and a thought leader. Chris is a mathematician by training, so you know he's a smart dude who has worked at both large enterprises as well as startups. Immediately prior to joining Question Pro, he was the global head of data science at Humanate, a global brand consultancy where he developed new methodologies, including the application of generative AI and LLMs. Earlier in his career, he managed advanced research teams, large software teams, and I know a bunch of agencies as well. I've known Chris for I think longer than we both care to admit, Chris, at this point, right? So,
yeah.
Awesome. So welcome to the webinar today. And what are we going to be doing? So we thought it'd be fun to play a little game. So we want to do a this or that. So a research method death match. So here are the rules. You'll see two research methods go head to head. I'll introduce them. Chris will talk about them and why he would use one over the other and in what situations. And then we would also like you to choose one for your research project. Which one do you want to do? Share your reasons in the comments. And there are no wrong answers. So let's see what we can do here. We have about 10 that we'll try to get through today, but both Chris and I like to talk. So we'll see how many we actually can get to. But all right, let's get this kicked off. And wherever you're viewing this on, whatever platform, add it in the comments. Let's see which method that you would choose. So first up, Chris, we have conjoint analysis or MaxDiff. Two pretty common ones, I'd say. Conjoint helps people understand and make trade-offs between features when choosing a product. And MaxDiff asks people to pick the most and least important items in a list, helping us rank preferences clearly. So Chris, conjoint or MaxDiff, when and why, or this or that?
Well, yeah, this is a good one because this is actually a constant decision we're having to make when we're running these kind of analyses. And, you know, a lot of it depends on what the structure is of the product or the things you are trying to test. If it's a grab bag list, then generally MaxDiff is the thing to do. So if it's, for instance, a bunch of product claims or something like that, then MaxDiff is the right way to go. Conjoint analysis assumes we can build a model which has attributes which are mutually exclusive. And that's a really important thing. A lot of people get tripped up on that and try and do a conjoint on things which it's not appropriate for. So for instance, if you were trying to do a conjoint analysis on pizza, you might have, you know, the 3 different type of crusts that you could have. You might have the 2 different sizes you have. You might have the different sauces you might have. And those are all nice attributes which are mutually exclusive. However, then it becomes a problem when you get to the toppings because, you know, if you say it's pepperoni, onion, if the topping levels are pepperoni, onions, jalapenos. Well, I tell you, if I'm having a pizza, I'm having onions and jalapenos on it. So they're not mutually exclusive. And so that becomes a problem when you're doing the design. So when you're thinking about putting together a conjoint, think about how you make that mutually exclusive. So very often, if you can't build that kind of model, you should be going with MaxDiff. And that's why, you know, I would say MaxDiff is probably 80% of the time the right answer. Having said that, if you were to force me, say, which is my favorite, I would say simple conjoint. And I will emphasize simple. The quality of a conjoint analysis is totally dependent on the model. And a simple model will get you better results than a complex model. always the case. Unfortunately, everybody thinks that the more complex the conjoint model, the model you put together, the better. Mathematically, that's completely incorrect. A simple conjoint model, something, pack size, brand, price, something as simple as that makes a great conjoint. And of course, conjoint, you need to be doing conjoint if you're looking for price sensitivity.
Got it. So MaxDiff wins here, you think, Chris, overall?
I use MaxDiff more than I use conjoint.
There we go. There we go. All right. We love them both here at Question Pro too, but MaxDiff wins. All right. That was a surprise for me. I thought you were going to go conjoint, honestly. I know. But all right. All right. So the first one is MaxDiff. Let us know in the comments what you think, if you would choose conjoint analysis more often or MaxDiff more often. So next one here we have stated importance versus derived importance. So stated importance is what people say matters to them. Derived is what actually drives their behavior. Often two very different things, Chris, as we know. So
very, very different. And this one's an easier one for me, I think, because whenever I can, derived importance is the winner here. The reason being, people are very bad at understanding what's important when they make a decision, and they'll say things that are different to what actually drives. So the example I always like to give is if you ask somebody why they bought a Mercedes, they will tell you it's because of the engineering, because of the features, because it's reliable, all these things. The real reason they buy the Mercedes is because it looks good in the driveway. Okay, but they'll never say that. Mm-hmm. They'll never say, I bought this Mercedes because having it in the driveway makes me look good in my neighborhood. Right. Okay, so stated importance is actually it can be useful. And if you don't have the room in the real estate in the study to build a full driver model, then stated importance obviously is what you need to go for. But you have to be aware that what people say is important to them and what is actually important in making a decision is often very different.
Got it. So you would go with derived when possible.
Importance. Yeah, if you've got the real estate and there are other caveats about the model you build, but derived importance if you can always.
So if someone is running a study and they want to do derived importance, but they don't think they have enough time or bandwidth to do it, or maybe the surveys are already running long, what does a good derived, methodology look like versus, and can I squeeze it in maybe, or what does that look like?
There are actually more modern methods for doing the derived importance, which actually work really well and actually don't take as much real estate in the study. So typically for derived importance, historically, it's been about a bunch of scale questions, on a scale of 1 to 5. How would you rate? Because you have to get derived importance, you actually have to rate a specific company, or a product. So maybe you'd be rating Mercedes on, all these different things, and then you would run a form of regression, which I think we'll get to later, a form of regression to get the derived importance. However, there are ways using simpler questions, select all questions. So you only have, imagine Mercedes, select all of the attributes that you associate with Mercedes, and you would have a list of those, and it's just a simple yes or no all the way down. You can run logistic regressions and things like that to get derived importance from that. And that often is a much quicker way, a much more direct way and robust way than the more traditional get a ton of scale questions.
Awesome. So derived importance wins. So we have conjoint, we have MaxDiff and then derived importance. All right. So next up we have k-means clustering. And I think let me back up. We skipped one. Oh, no, I guess not. Okay, anyway, we have k-means clustering or latent class analysis. So k-means clustering is grouping people by similarity using distance and data. Latent class analysis, or LCA, as they say in the biz, groups people based on hidden patterns in how they respond, more flexible and often used for segmentation. So, Chris, k-means clustering or latent class analysis? What are the two, and when would you use one versus the other?
Yeah, so this is another example where, I mean, these are techniques. Both of these techniques are techniques I use a lot, and they're very different depending on what's the data you have, what is the kind of data you have. Latent class analysis tends to be better suited to the kind of data that we get from research surveys. The reason being is that latent class analysis works well with categorical data, with yes, no answers, those kind of things, and basically we'll build groupings based on those. K-means clustering specifically is about a continuous n-dimensional space, meaning that you have to have a lot of continuous variables. And it will cluster you in those continuous variables. Now, in market research, we don't always have continuous variables. Okay, we might ask, 5-point scales, 7-point scales. We kind of approximate those and say they're like continuous scales. They're not really in the way they're used. So k-means clustering, while it is usable on that kind of data, that's not the ideal data for it. So if you'd asked me this 5 years ago, I would have said latent class for everything. Now, the irony being is I'm using k-means clustering a lot at the moment in my own work, because we have these magic things called embeddings. For those of you who may not know, when a LLM produces, when LLMs like ChatGPT and the others, when they do their analysis, one of the things they do as an intermediate step is embed the text into a multidimensional vector, usually about 1,500 dimensions. K-means clustering works fantastically on that, and you can do some really clever and fun things in that embedded vector space. So I'm going to say latent class analysis for market research, but be aware that k-means clustering and other related, there's a whole family of clustering techniques around this, but those related techniques are becoming more and more important when we look at text analysis.
Got it. Okay, so it really depends on what you're trying to accomplish here, but
absolutely,
this is a research webinar after all, Chris. So we got to go with.
So latent class is going to win for research analysis.
All right. There we go. There's got to, if it's a death match, there's got to be a clear winner, right? So in this case,
you realize that this is the reason why I only have one son. It's so I don't have to choose favorites.
There you go. Exactly right. There was one question that came up, and I'll ask it now. Like, what do you mean by continuous variables?
Right. So a continuous variable is one that can take any value between two numbers. So, for instance, if something goes between 0 and 10, a continuous variable would be a variable which could be anything. Could be 3.8, could be 7.2, anything in that range. Okay. Now, we rarely have continuous variables in market research. We have 1 to 5, right, where only the integers 1 to 5, and that has different mathematical properties, which k-means isn't perfect for. It can be used. Don't get me wrong. I mean, it's been used as a staple of segmentation for decades, where people have taken the answers 1 to 5 and done k-means clustering on it. That's not intrinsically wrong. However, latent class is better suited for that kind of data.
Got it. Okay, yeah, they said thank you, so appreciate that. And regression or correlation. So regression tells you how two things move together, but not why. Regression shows the strength and direction of influence, how one variable affects another. So Regression versus correlation. What say you, Chris?
So this is one that's gonna maybe surprise people a little bit, because my final answer here is going to be correlation, but I'll explain why. Because
Oh, wow.
simple linear regression, if you've got a bunch, let's say you have a bunch of 5-point scales, and you want to do a regression to see whether it's a driver or something. If you do simple linear regression, it is not going to work. The results you get are going to be misleading. The reason, there are a couple of reasons for that. One is, again, the nature of the data is wrong for regression. The 1 to 5 really, it's not. Our data is very rarely normally distributed, which is one of the assumptions in standard linear regression. And also, the one that really kills it is there's high multicollinearity. So if you're asking people to, rate the service on a scale of 1 to 5, rate the service for the person you first spoke to, for the communications, what's going to happen is they're going to be very highly correlated with each other. When there is high multicollinearity, in other words, the things are moving together, linear regression will give misleading results, standard linear regression. So generally, if somebody's looking at, what's the driver of something, I would say stay safe and look at correlation, which is basically where you say, how is this one variable correlated with our outcome variable? And if you do that, you're not going to get into statistical problems. However, having said that, there are techniques, there are more modern regression types that actually take multicollinearity into account. So things like partial least squares regression, or principal component regression, or things like that, actually take into account that multicollinearity. However, they're a lot more complex to apply. I mean, you have to do more work. So I would say generally, and this will probably surprise people, go for correlation, because then you will know you are right. If you're going to go for a regression, talk to a statistician first, because just running linear regression, you're going to get totally misleading results unless you really know what you're doing.
Yeah, that surprises me. I thought you were going to say regression, because you always hear correlation doesn't equal causation, right? So you always want to know what it is that's causing these things. So that surprised me. And I know there were some questions, but I want to keep things moving. We'll try to get to those at the end if we can. So, all right, correlation wins here. So let's move on and see what else we got next. So we have attitudinal data versus behavioral data. So attitudinal data tells us what people think or feel. Behavioral data tells us what they actually do. So this is kind of similar to maybe stated versus derived, or how do you see this as a difference, Chris?
So this is definitely a porque no los dos. This is for this, it depends on what you have access to. Behavioral data is incredibly powerful when you have access to it. Okay. Right. Now, you can ask people, you can have stated behavioral data. Did you do such and such? Which we often do in surveys, and is a reasonable thing to do. However, people's memories are actually pretty poor. Yeah. I actually, with a peripherals manufacturer a while back, we actually had some telemetry data on their devices, and we actually did a test of whether people really were saying correctly. So we asked them when they did a particular action, how long ago it was on their device. And people's time spans are really poor. If you say to somebody, have you done this in the last 3 months? Right. You are probably going to get all the people who did it in the last year, not in the last 3 months, simply because people don't have that good memories, especially if something's not that important to them. So if you have true behavioral data, so either if you have telemetry through a device or through a website, or if there are companies out there where you can buy behavioral data of things people have really done, it's incredibly powerful. It's very complex to work with. That just be aware. You need a data scientist involved somewhere if you're going to work with behavioral data. So, asking people how they feel about things, you're never going to get that through the pure behavioral data.
Mm-hmm.
You are going to get it from the attitudinal data. You are going to get it through qual as well. I'm a big believer in mixing all these things. So this is the one where I'm going to say all of the above, because I'm a big believer that we should be doing qual. We should be getting attitudinal feedback through surveys. We should be getting quantitative data. We should be asking people what they think their behavior is, and we should be measuring what their behavior actually is. So it's really, you should be using all of the data that you have available to you.
Got it. I thought you were going to say derived, just based on, you selected that one, and behavioral data kind of seems more closely correlated to that. But all right. So there's no clear winner here. Use both of these accordingly, I guess, right?
Yeah,
so
exactly.
All right. Okay. All right. Fair enough. All right. Synthetic data or real data, Chris. I think this one is right up your alley. And I think it's pretty clear what these things are, but just for people that may not know or want some definition, synthetic data is artificially generated but modeled after real patterns or people responses. Real data comes from actual respondents, or so they say. And synthetic is great for testing when the real data grounds us in truth. So the both are, obviously need to be somewhat related, I would say, right, Chris? But I mean, because you need real data to create synthetic data. But what say you in terms of synthetic data versus real data?
Yeah, and I'm going to start this by saying that not all synthetic data is created equal.
Sure.
If what you're saying, if what people are saying is just go to a model, just go to Google Gemini or to Chat GPT or whatever, and ask a question, that's useful directionally, but it's not real data at that point. Right. What you're getting is how the model has chosen to present that. And unfortunately, because that's a very easy thing to do, and because these models are designed to be plausible, you have to remember that plausibility is the primary training direction that these things are trained on. So they can produce something that's plausible but completely incorrect, which is, and they're getting better. We're seeing a lot of movement towards better factual responses. But if that's all you're thinking about with synthetic data, yeah, that's not really that useful. Now, what a lot of us are doing, and we're working on, others are working on as well, is this idea of being able to take real data and somehow expand it, or either through extrapolation or interpolation to get new data, and that can be incredibly powerful. And especially when you want to get fast indicators of something, again, like most of insights, everything is, a speed cost accuracy trade-off. That's right. That's always been true. It's true now. And based on what your business needs are, you may actually lean towards some synthetic data. But however, one of the things I believe, and I think most people are moving towards as well, is that the most reliable synthetic data is the data that's built up on top of real data. So you already have an individual, a persona, somebody where you know a lot about their choices and how they make decisions. And then you say, what would this person have said if we'd asked them such and such? And the indications are very promising that we can get very close to what the real individual would have done. So synthetic data is, I see it as really a layering on top of real data. So this is definitely an and. I think that what we're going to see, sometimes I use the expression three-dimensional research, which is this idea of having qualitative, having quantitative, and synthetic, and those three different ways of looking at things and bringing them all together. In the end of the day, well-collected real data will always win. Okay. But I emphasize the well collected,
Yep.
well collected real data will always win.
Right.
However, synthetic data will be another tool amongst our amongst our abilities to actually say, hey, can we move quickly in this direction? What do we need to know? How do we need to understand this better? Can we get a bit more color, a bit more depth into this? So for a lot of people say it sounds a bit bogus. For those of us who've been doing statistics for a long time, and you can probably tell I've been doing statistics for a long time, I feel the same about synthetic data as I did when I first came across this the statistical method of bootstrapping. That's a little niche, but if any of you in the comments are statisticians, you remember when you first came across bootstrapping, and you started by saying, this can't be right. This is too good to be true. This is voodoo. This is magic.
Right.
And then once you start to understand bootstrapping, you suddenly realize, hey, yeah, I can take this group of 1,000 people, and I can get better than the normal statistics would tell me is the case.
Right.
I can actually do this. So I actually, for those of you who are statisticians, I would say synthetic data is like bootstrapping on steroids. It's a way of getting more out of our data, but the key is it starts with data.
So no clear winner here, Chris. Well, that's what I'm hearing.
I mean, if you only could have one, it would be real data. But synthetic data is going to become more and more important.
Makes sense. Yeah, I think most people would agree. It's kind of what I'm seeing in the comments as well. So, all right. So real data when it's real, and synthetic data becoming more common. Okay, awesome. All right, let's move on here. So we have another one here. Bayesian statistics versus frequentist statistics. So some people might not be familiar with either of these, Chris. So Bayesian starts with a prior belief and updates it with data, from what I understand. And then frequentist relies purely on the data at hand without prior assumptions. Is that a fair definition of both of those?
That's a fair definition. And, one of the things that's interesting with this is that this is a religious discussion.
Oh boy, I didn't know that was going to come up.
The interesting thing is it's far less of a religious discussion now than when I first started, 20 or so years ago. The reality is, so for those of people who don't know, frequentist statistics is all about hypothesis testing and all about significance. And, it all came about from, actually, there's some interesting history there. If it all came about from somebody at the Guinness Brewery wanting to understand what he could rely on from the tests they were doing in, I think it was in different barley harvests or something like that.
Huh.
It's got an interesting background anyway.
I like it.
This whole idea, and it goes back a long time. The people like Fisher and Pearson and all the old names of the greats of statistics. The idea is that the core of frequentist statistics is saying what would happen if I repeated this experiment again? What can I say about what is likely to happen if I repeated this experiment again? And that's where things like statistical significance comes in. And by the way, for those of you who are not statisticians, I can promise you what you've been told statistical significance means is not what it really means. Okay. A lot of people think that if something's statistically significant, it's important. That is not true. Okay. Something can be statistically significant and not at all important. Something can have a low statistical significance and be true. Okay. What it means is, what it actually talks about is what would happen if we repeated this experiment multiple times. The p-value, a lot of people think that things like p-values, if you've got a p-value of 0.5, that means that there's a 95% chance that this is true. That is not what statistical significance means. Okay, so just it's one of those things. Interestingly enough, that kind of gut feeling, the popular way that people imagine statistical significance meaning, is actually what Bayesian confidence intervals mean. Most people, so people actually think Bayesian, even if they're not, even if they're working with frequentist statistics. So it gets very complex. A lot of it is way above me. Even though I've studied statistics and I've worked in statistics all my life, there are parts of these that just go way beyond, and you'd have to talk to somebody who cares about this. The thing about Bayesian statistics is when it was first kind of formulated and proposed, people didn't like it, and they didn't like it philosophically. They didn't like it philosophically because, as you mentioned, Dan, it starts with this idea of a prior. What's my original belief about this? Right. And people thought, oh, that's all very squishy and not very scientific, which is actually not true. But that was the major pushback about it, is that people felt it was very squishy, very and had so many assumptions in there that it wasn't useful. And then what happened was the internet, and all of a sudden, the statistics that successful companies on the internet started using was Bayesian, not frequentist, because Bayesian works. Okay, Google, the small company you may or may not have heard of, Google. Google went all in on Bayesian statistics in their original design. Sergey Brin, the founder of Google, went on record as saying Bayesian statistics is the crack cocaine of statistics. Okay. Because the way Bayesian statistics works is you start with quotes a prior, which is what do we believe before we've done any experiments? Okay, where do we think it might be? Okay, how is that distributed? And then as you collect data, you treat that data as evidence to modify your belief. And you do that over and over again and over and over again. And the trick is, this is a numbers game. This is why the internet made everything change, is all of a sudden, if you've got 100 million, 1 trillion data points, all of a sudden Bayesian statistics suddenly becomes very, very attractive because it gives you a very accurate view through this constant refining of your belief in where the prior is. Pretty much the argument, 20 years ago, people may have argued against Bayesian and saying, oh, I don't believe in Bayesian statistics. You can't do that anymore. I mean, that would be like going to Google and saying, you don't know what you're doing. Well, they did know what they were doing.
Clearly they know what they're doing, yeah.
So in terms, now, how does that affect us? The reality is for research, I was going to say 9 times out of 10, but I'm going to say 7 times out of 10. Okay. Frequentist statistics is the right thing to do. Okay. However, there are certain things. So, like we've mentioned MaxDiff and Conjoint. For both of those cases, we use Bayesian statistics to do the analysis. The methods actually start with a prior, where we think the utilities are going to be distributed, and then we use the evidence of each of the exercises that the respondent does to actually modify our beliefs until we get to it. So if you're going to force me, I'm going to say Bayesian statistics.
I knew it.
The reason being is that I think it's more fun, and it's more how the world works. Frequentist statistics works on an assumption that everything is an experiment.
Got it.
And the world isn't a bunch of experiments. The world is a bunch of behaviors and beliefs about those behaviors. And I actually think that's a better model of the world.
I do like the frequentist and how that came up though with the Guinness example. So
Yeah,
it's
yeah,
Guinness against Google, I guess. So pick one, I guess.
exactly.
All right, cool. All right, so Bayesian wins out here. Next up, we have key driver analysis versus relative importance weighting. So key driver quantifies what drives an outcome like satisfaction. Relative importance shows how much each factor contributes to the big picture. So which one, Chris, and when would you use one versus the other, and which one wins out?
Yeah, this is a really interesting one because these are both techniques we use a lot when we're trying to analyze how something changes. What is it that makes my NPS go up or down? How do I understand that? And both of these techniques are used. With relative importance weighting, actually that's a relatively new technique. We're talking, technique in the last 20 years.
Oh, wow.
Which is really a way of saying what is the contribution of each of the potential drivers to the outcome, okay? And how do they match up, okay? Now, people used to do that using simple regression. Now, I've already talked about simple regression and how typical just doing a linear regression is probably not what you want to do, largely because of this issue with multicollinearity and the general correlation between the drivers. More modern techniques like Johnson's relative importance weighting, which is relatively new, like I say, within the last 20 years or so. The thing about relative importance weighting is it takes that into account and it provides a measure of how important each driver is. There are other techniques. There are techniques like Shapley and other ways to kind of get the relative importance of each driver. Personally, the one I use all the time is Johnson relative importance weighting. There are others that are similar. Or you can just use simple correlation, as we discussed before.
Right,
Relative importance weighting is robust and provides very good results as to what is really driving. What it doesn't do is it doesn't give you a model. You don't get a model out of it of, if I were to change this, what would then happen? So if you find your NPS is highly driven by people's stated experience with your call center, it's what relative importance weighting is going to tell you that's important, but it's not going to tell you what's going to happen if you manage to move the needle on getting better call center satisfaction or whatever.
Right.
For that, you do need to build a driver model, and that's where key driver analysis comes in. Historically, that's been done with simple regression. Again, generally, there are a lot of problems with simple regression when it comes to this kind of thing. Personally, I use partial least squares regression instead of simple regression. Partial least squares regression is a form of regression that basically transforms everything to a different space where things aren't correlated before it builds the model in both directions, which is kind of what makes it interesting. But it gets around a lot of the issues of correlated drivers and things like that. Other similar techniques like structural equation modeling, I will go on record as saying I personally do not like structural equation modeling, but there are reasons for that. But a lot of people use it very successfully. Right. That's another way of doing it, but that's a big exercise. There's no such thing as a simple structural equation model. But basically, you build key driver analyses if you want to build a model which will give you the what if of what if we change this. Of these two, I'm going to let relative importance weighting win, largely because it's very generally valuable. Like, it's something that everybody should do if they're doing that kind of driver analysis. It's robust. It gives you a very good view of how important different things are. And it basically, it's basically a great way of understanding what's really important. And it's a form of derived importance, to go back to one of the
Right.
discussions we had earlier.
Okay.
I really like Johnson's relative importance weighting.
Awesome. So the new kid on the block wins. I like it.
Yeah.
And that was a question that came up around derived importance versus, the relative importance and some of the things you were talking about there. So thanks for answering that question that you didn't even know was asked. So I appreciate that. Awesome. And then, so this is also, I think, kind of near and dear to your heart as well, Chris, topic modeling or sentiment analysis. So for those that maybe, just some definition for the two of them. So topic modeling uncovers themes in open text, and sentiment analysis gauges emotion, essentially. So what do you think here, Chris? I'm guessing you're going to say there's different use cases for them, but I'll let you say it.
Yeah, I do have a favorite in this case.
Okay, all right, good.
Let's take sentiment analysis first, because more people are probably familiar with this. It's been around for a long time. There have been versions of sentiment analysis around pretty much ever since we've had text and computers and the internet. It's some form of it, and old school sentiment analysis, where sentiments are basically done as positive, negative, or neutral. That's been around for a long time, and 15 years or so ago, the big promise was, we're not going to do any more research. We're just going to monitor social media and do sentiment analysis. That's all we need to do. We don't need to run another survey. We'll just monitor. So we'll do social media monitoring, and we'll do sentiment analysis. And of course, that never. It's always been useful and people have done it, but the big hype promises that it was going to change the way we did market research never happened. And part of the reason for this is something I call the Italian flag. Okay. So the Italian flag is the red, white, and green. Okay. And the typical sentiment analysis was, red for negative, white for neutral, green positive. We've all done it. We've all done the Italian flags. Here's the problem with the Italian flag. Okay, look at the white, the neutral. What does that mean? Does it mean it's neutral sentiment, or does it mean we didn't extract sentiment? Those are two very, very different things.
Yeah, and
we pile the two into the same. And what that means is, because that is unknown, it means the percentages at either end don't really make a lot of sense. So even going way back before we had some of the tools we have now, what I was doing with clients is what we call butterfly diagrams, which is where you take all the people who are genuinely positive, take all the people who are genuinely negative, and then you do topic modeling around those two and say, what do people who are positive talk about? And what do people who are negative talk about? And you build a diagram. We call it a butterfly diagram because it's two wings. And the reality is that's really insightful. People can look at a butterfly diagram and say, "Oh, okay, this is where we're doing well." The people who called into our call center. Okay, when they talk positively about us, they talk about this, they talk about that, they talk about this. When they talk negatively about us, they talk about this, they talk about that. That combination of sentiment plus topic modeling is very, very insightful. You can get a lot out of it. So if you're going to force me to pick one, I would pick topic modeling, because I think it gets more to what people are talking about. Combine the two with sentiment analysis and topic modeling, and you get something really powerful where you can actually start to make decisions based on what they're talking about.
Yeah, that's good. So topic modeling wins out here. I do like your Italian flag example, and I think you're right that white space is often that you couldn't derive sentiment, right? So it's not that they're neutral, it's just nothing could be derived from what they said, which is it's an interesting problem, I would say.
And it has to be said, and I wrote an article about this a couple of months back for Martech magazine, where the more modern with the more modern capabilities with LLMs and using some of the the k-means clustering that I talked about earlier, you can actually go a lot deeper into sentiment. You can actually do emotional analysis of what are people feeling when they're talking, which is emotional analysis goes one step deeper than sentiment analysis. But again, it's very powerful. And with modern tools, we can go a lot deeper into that.
Awesome. So topic modeling wins out, but you said this for a couple of them. When you can combine them, both of these are powerful. So
yeah, absolutely.
Okay. So this might be the last one. Maybe we have a bonus one. We'll see here. So cross-sectional study versus longitudinal study. So cross-sectional captures a moment in time. Longitudinal tracks the same people over time. Great for spotting trends and changes. So cross-sectional versus longitudinal, Chris. What do you say?
This very much depends on the business question. And when we talk about longitudinal studies, there are actually two different types of longitudinal study. One where you're actually trying to talk to the same group of people over time. And you can do that through things like our communities product and things like that, where you can get true longitudinal studies through them. More often, if you're talking about normal surveys, we would actually identify a cohort, like a specific screener, which says we're speaking to the same kind of group of people, whether it's decision makers in such and such an industry, treat them as a cohort and go through. And it's basically what I would say here is, if you can, longitudinal studies give a lot of insights that cross-sectional studies don't, in the sense that they tell you how the market's evolving and how your own performance is evolving as a company or as an organization. And that is very insightful. And I love working with longitudinal data. There's techniques you can use for it to really understand what's going on over time. However, it's a lot more of a commitment. It requires a lot of planning. It requires a lot of stakeholder commitment, because to keep that expenditure going quarter on quarter or half on half, however you're doing it, requires a lot of backing and a lot of investment potentially. For obvious things like customer experience or brand tracking or things like that, it's the natural way to do things, and actually that's how to do that. I think the advice I would give is, for people who are designing a one-off study, always step back and say, if we wanted to rerun this and to track, what would we be tracking? Okay, and let's make sure that we're asking the questions in a way that we could track this in the future if we find we get data that we really want to get on top of. And so treat every cross-sectional study as a baseline. Okay, I like using the term baseline. If you treat everyone as a baseline, then maybe you'll want to say, actually, we should be tracking this on a regular basis, and we should be doing it longitudinal. So I would say longitudinal wins for me. But the realities mean that sometimes you can't commit to that. But then treat your cross-sectional studies as baselines that you may come back to.
Got it. All right. No, that makes sense. So longitudinal wins out here in the death match. So I think this was the last one we wanted to cover, but Chris, I want to do a bonus one for people, if you don't mind here. Let's go. Let's do Van Westendorp versus Gabor Granger. So this is a pretty common one, right? And if you want to do any sort of pricing, you've probably come across these two. Gabor Granger tests one price at a time to find how demand changes. Van Westendorp asks about price perceptions, like what's too expensive, too cheap, and so forth. So Gabor Granger versus Van Westendorp. Chris, what do you say there before we wrap this up?
Okay, so this is one that could be longer, could be a lot longer, and people
Okay.
may be slightly surprised by my answer to this.
All right.
So Gabor Granger works really well if you have a specific, fully described product that is well known to the respondent, and you want to identify what the price sensitivity is going to be of that product. So if you know it's going to be exactly this product, hey, look, here's the package, here's the thing. Gabor Granger works really well for that. Okay. There are some downsides. It does tend to require more sample size because you're not getting as much information out of it as you maybe are with some other techniques. But you see, both Gabor Granger and Van Westendorp are attempts to answer the unanswerable. And the unanswerable is willingness to pay. You cannot go to somebody and say, what are you willing to pay for this? Okay. There are, for so many reasons. One is that people, will always say the very cheapest possible, I'll pay shipping and nothing else, which is actually interestingly something that, companies like Temu and AliExpress actually have leaned into. They say, people only want to pay the shipping. Bang, let's do that. It's almost an unanswerable question. Okay, what are you truly willing to pay? People can't answer that question. So both Gabor Granger and Van Westendorp attempt to circumvent that one way or another. Okay, and they do so in different ways. But Gabor Granger works well if you've got a very well-defined product and very specific. Okay. There's this other problem as well, which is what's called anchoring, which is the moment a number has appeared in a survey, it will cause people's brains to anchor. This is a well-known effect in behavioral economics. It's the reason why when you go into Nordstrom's, you go into the handbag section, the $12,000 purse is right at the front, so that when you get to the back and you see the $1,500 purse, you think it's a real bargain.
Yeah, makes sense. Yeah.
And so it's well known, this idea of anchoring. The moment that you've seen something, the moment a number has been mentioned, and so this is a problem. Okay, so let's get to Van Westendorp. I'm going to talk about Van Westendorp in two different things. One is the set of questions. I actually think the set of 4 questions is a work of genius. Okay, yeah. If I could meet Van Westendorp in person, I'd say Piet, well, however his name's pronounced. That's a work of genius. Well done. I'll buy you a beer. The second part, the analysis, is as he's drinking the beer, I'd be saying to him, what the heck were you smoking when you came up with those lines? Because I can tell you, I have been late night in bars more than once with PhD statisticians as we've been arguing how to interpret those lines. Okay. Everybody sees it as a bit of magic, and everybody has their own way of explaining why the crossover of this line and this line makes sense. It doesn't. Don't even try. Okay. Now, it turns out that it actually ends up with a pretty good approximation to what people's range is. But what I'd say is don't put too much store in the very specific points. Okay. A lot of people take the crossover of the lines in the Van Westendorp, the traditional Van Westendorp analysis. They take it as read, and I think just remember that none of us really know what Pete was smoking when he defined those points. So it's very useful. I actually think the question set, because of the way it's asked, and be careful of the order you ask them in as well. Because of the way it's asked, it's a very good way of getting an individual's understanding of what the acceptable price range is for something.
Right.
There are extensions to the Van Westendorp. One is called the NMS extensions, Newton Miller Smith. And that extension adds two questions, which is how likely would you be to purchase at the bargain price? How likely would you be to purchase at the getting expensive price?
Mm-hmm.
And it turns out that if you have those two questions, you can actually build an analysis which is actually a lot more defensible and a lot more, it's a lot easier to see, okay, so what's actually happening here?
Right.
Personally, pretty much whenever I run a Van Westendorp nowadays, I use the NMS extensions. There are other extensions that people have proposed. So I don't want to take away the genius of the question set. I think it was genuinely good. I would take the traditional analysis with a pinch of salt, because like I say, every PhD statistician that I've ever had this argument with has a very different way, and most of them agree at the end of the day, yeah, it's 4 lines and they cross over. Unfortunately, what's happened, and I don't think Van Westendorp did this, I think this was done later by somebody else, they put labels on the lines of, the point of marginal utility, and they sound great and they're meaningless. So, so use the analysis as a guideline. It still makes sense that the point between those two crossovers, that is going to give you reasonable ranges, and so it is valuable for that. But just don't read too much into that, and I'm sure I'm going to get a lot of hate and flack in the comments for that. But yeah. So personally, of the two, the one I prefer is Van Westendorp with some extensions to that, like the Newton-Miller-Smith extensions.
All right, I like it. I thought you were going to go Van Westendorp, by the way. So that's good. That's good. Awesome. Well, I think that concludes our time today. Chris, thank you so much for your insights and participating in the death match. We'll have to do this again. I know that there are many other methods that we could probably compare and contrast. So this was a fun format. As Judy here says, she liked the format and appreciated the refresher. So thank you, everyone. If you have any questions, feel free to put them in the chat, and I think we can get a download of these and maybe answer the ones that are important or that make sense that we need to address. So we will do that. And then if you want to connect with us, both Chris and I are here. There's our LinkedIn's. I think we're both pretty active on there and respond to messages and so forth. So now you know where to send all the hate mail to Chris on LinkedIn there if you need to. So feel free to get at him. And with that, before we wrap up, we do want to invite you all to X Day. So X Day is our user conference that marketing says it's a fun conference that is actually a good conference to come to. And I would agree. We've been doing this for the past 3 to 4 years. Chris was there last year. So if you want to register, we'll put a link in the comments, and also I'm sure you'll be hearing about this more and more from us. But please come. It's a 1-day conference on October 9th. You can use this discount code Dan100, or you can use Chris100. So we'll have our own death match here with the codes, Chris. So Chris100 or Dan100, and join us. There's a link in the comments now. It's a very fun event. We have a whole lineup of speakers, both on the research side, the CX side, and the employee experience side as well. So come join us in Austin and come hang out for a little bit. So there you go. With that, we'll go ahead and wrap it up. Chris, as always, thank you very much.
Thank you. And for those of you who can make Austin, you can bend my ear about why you think Van Westendorp is good.
Yeah, sounds like some good late night bar sessions there, Chris.
Exactly.
So. Awesome. All right. Thanks, everyone. Have a good rest of your day. We'll talk to you later.